Are we ready? Yes. So, welcome back to our second session here at Science Innovation Day. This is arranged by STC Research Center at Mid Sweden University. My name is Kristin Grafström, and I will guide you through these sessions. And I want to inform you first that this session is recorded and broadcast live on Mid Sweden University YouTube channel. So if you don't want to be on the recording, save your questions till break. Otherwise, just feel free to raise your hand and ask your questions during the presentations. So now we will start. We will talk about how to visualize data to get better impact. So I leave the word to Emin, Zerman and Roger Olsson, researchers at Mid Sweden University. So thank you.
Yeah. Hello everyone. My name is Emin Zerman. I'm an associate senior lecturer. I'm working on visualizing data. And
my name is Roger Olsson, researcher and working also at visualizing data.
Yeah. So we are bombarded with numbers in our daily lives, basically, so that we sometimes know what they mean, and sometimes we are basically appalled by the sheer volume of the numbers. And then in order to understand what do they mean, we sometimes need to step back a little bit. And even then, if we step back, then it might not mean so much to us, because we need some kind of an anchor, some kind of thing to measure or compare to. Then we can try to find the patterns, different patterns, and then we can try to find perhaps what is where this number fills in the scale. So is it kind of like a minimum number, maximum number? Can I somehow make this visible so that I can see what's going on with the pattern? And then perhaps I say, okay, I can assign cold values to minimum numbers and hot values to maximum numbers, so that now I can see something, and then I can then aggregate all these information, and then perhaps I can see, okay, yeah, there's a trend, and also there's a message that global temperatures have increased by over 1.2 Celsius degrees. So that might be the message, and that might be the insight. But I don't have that without visualizing the data and seeing or analyzing the data and this brick of numbers. So data visualization gives us this message, this kind of succinct information from all these kind of data. And then if you are clever and if you know your way around, then you can also have a very impactful visualization like this, so that it's like a barcode. Have you seen this before? No, none of them. Okay, perfect. So this was kind of circulated through social media and the internet, and then it's basically showing the same thing from 1850s to 2022. It is basically the mean temperature around the world, and then if you know what it means, then you can recognize it everywhere. So it gives you basically this idea that can permeate many different media. And data visualization can be a way to go beyond numbers. And we will try to succinctly give that information to you today. And then it can be easy to understand or sometimes hard to understand. It can be beautiful or ugly or perhaps useful or not so useful, depending on the complexity of it. So we are going to do a dynamic presentation here, so that sometimes I'm going to talk, sometimes Roger is going to talk. So I'm going to now give the scene to Roger.
Yes. So who are we? We are representing a research group at Mid Sweden University called Realistic 3D. And we have a few different areas specializing in image processing and machine learning, deep learning, virtual and augmented reality. But we're here today to talk about visualization. We're, in addition to the research that we're conducting underneath the STC Research Center, we also are at the process of starting up a master program specialized on visual AI. That is an intersection then between visualization that we'll talk about today and artificial intelligence, which we also will touch upon a bit during this talk. The visualization research that we conduct are split up into a few projects, or quite a few projects over time. We are working on company close collaborations where we, for example, have a visualization project where we aim to enhance the manual welding procedure by giving visual feedback to welding to increase the end result. We have InfraVis, which is an infrastructure for visualization within Sweden for facilitating research in Sweden through visualization. We have InfoVis, which I think you will talk more detail about later on. It's we also have other projects, Metodvis, Skolvis, which are visualization efforts to try to enhance different processes. Metodvis is to enhance the research process. Skolvis has been to enhance processes within the schools, pre-university, and we have had previously visualizations of illustrating what is fresh air. How can we make us understand what fresh air is and convey that message? So, but today we would like to take you on somewhat of a journey beyond numbers, going from the numbers that we have that is produced in our everyday life, in our different organizations and processes. We have a goal in this journey. We can see that goal. As we all know, there's not necessarily always a straight line between where we are and where we want to be. So we will make a somewhat of a winding path, but we will then, through this winding path, also have the option of stopping at certain points where we think there's good places to stop and share the view. One is, what is visualization? Because visualization is a big word, big concept. It's interpreted in different ways, in different settings and by different people. We should somewhat make a common ground here for the later discussions. We should look into how we can find insights through visualization, because that's the thing here. We want to use graphical representations to understand things that we wouldn't be able to do otherwise. If we were to be able to see the content in all those numbers, we wouldn't really have to have visualization. But as we saw, those numbers are just a big wall of numbers. So we want to find insights. And then obviously, everyone has to somehow relate to AI. We heard that this morning. We've heard that before. That is also true in this context, obviously. How can we use AI to enhance our visualization efforts and endeavors? So, what is visualization? Visualization has been around for a very long time. It has been around all the way where multivariate data was presented to illustrate the Napoleon, one of the Napoleon Wars, right?
Yeah, Napoleon's expedition to Russia.
Where their Napoleon soldiers walked to Moscow to try to take down the Russians, I guess. Okay, I shouldn't diverge into my ignorance of history, but I could stick to the visualization that one illustrated the amount of soldiers going from left to right, going through time in the same picture. So the width of this, if you can call it line, is the number of soldiers at a specific point in space as well as in time. And we can see that there's a diminishing width of this line as a result of the soldiers actually dying then on this walk to the east. We can also see splitting up of this line into small sublines, which just indicates that a portion of this group of soldiers moved in a different direction in a different time relative to the bulk of the population, if you can say so. And then we also see the black corresponding line, that is the amount of soldiers then going back from having reached Moscow and then trying to come back. And there's a lot of things illustrated in this very condensed image. We have map information, we have temporal information, we have the number of people. So we can actually, by just looking at this, infer quite a lot. There's also temperature information that is kind of crucial in this case as well, because a lot of people or a lot of these soldiers died due to cold, not necessarily due to the act of war, so to say. And you can measure the size of these, for example, to illustrate the relative number of soldiers actually coming home after having went out into war. So this was something that was presented very long time ago, but still is a very informative visualization of data that you might have access to.
You can go on.
Another visualization is the cholera cases in London. This is also then just to give us a historical framing of what visualization is. It's not just that we have computers now allowing us to do visualization in a very nice manner, but the actual foundation of visualization has been here for quite some time, and that should be leveraged when even doing your visualization on your computer. So cholera cases, it was not clear why people died with such an increased rate in London until one started to plot the actual position of people dying on a map. And the size of these circles indicate then the number of people dying in that specific area. And by looking at it from that perspective, it started to become apparent that the cases of death was centralized around a specific point. And eventually one found out that that point was a well, and that was when you started to infer and started to understand what was actually causing cholera, because the problem was you didn't know why people died. But then you found out that, okay, it's something to do with the water, which is then a consequence of visualization. Gaining insight into your data by visualizing it. So at the pump station was the geographical position where you can then infer that these cases were emanating from. So there's this process of producing graphics, images, diagrams, which we then say is visualization, or define as being visualization. And the purpose of this visualization is not to create the images, not to create cool looking graphics, but rather to provide a basis for insight that you would not be able to perform or achieve rather without transferring the numbers to graphical elements.
Yeah, then we can try to say, okay, how do we get insight then? Like, we can now try to play a little bit data detective because we have data, we have visualized it in a form that I'm going to show you now in an interactive form that we have access, and then we can try to do something. So that I'll try to show you basically a kind of this interactive visualization, which is not something we made, but we basically utilize to make a point. So that this is an interactive visualization, and each bubble corresponds to a country. The size of the bubble it represents its population, And the color represents the continent, so that the yellow color represents European countries, red color represents Asian countries, etc. And then on the x-axis we have the income, which we can change. We will change in a minute. And on the y-axis we have life expectancy. And then you can see there is a strong correlation between income and life expectancy. That means that richer people have also higher life expectancy as well. And also we have something of a time axis at the bottom, so that we can also see how this changes throughout time. So it can start from 1800s and then towards coming to our day. Basically, European countries are getting richer and richer, and then they're getting higher life expectancies, and then other countries like USA also leading at the forefront. And Asian countries also kind of catch up at some point after the Second World War or so. And then we have always, throughout the time, we have this strong correlation with the income and life expectancy, so that we can see. So what can we do to, let's see, try to change this? Instead of life expectancy, can we perhaps let's try to analyze how child mortality is related to income. And then I can go back to again 1800s, and then I can see that child mortality is not very well correlated with income, because no matter what the income you have, you had more or less the same child mortality in 1800s. So then we can do the same thing. We can try to increase the time a little bit, and then you can see that the countries are kind of getting less and less child mortality, and then this is both due to increased amount of income and also the advances in medicine and the different technologies, etc. And this is nothing it is unfound of, but then we can also try to find perhaps something different, so that I can try to say check democracy score versus income. And how does this change? Oh, okay, this is something different. So there is no direct correlation between income and the democracy score, so that I cannot infer anything from that. But then I have also can change the x-axis and then try to see, let's find out perhaps, I don't know, I can also type in the GDP or happiness. Yeah, let's try happiness as well. And then I'll try to check that with respect to GDP, for example, inflation adjusted GDP. And then, so x-axis means GDP and happiness score is on the y-axis, so that we have, again, a kind of strong correlation with GDP per capita and happiness. So this is type of thing that we can try to do when we have a big volume of data and we are trying to understand it, analyze it, and get to an insight using data visualization and visual analytics. So that was just one example. We can have other examples as well. I'm not really sure. Let me check the time so that to leave time for questions as well. Here's another one. I'll show very quickly what the world eats from National Geographic, so that we can have a quick look at it, so that this is basically a visualization of what we eat. And then you can have different type of things, calories per person, grams per person. On the left-hand side, you have a little bit of this kind of information. Right-hand side shows different type of countries, different USA, Argentina. I'm not really sure Sweden is there, but there are different countries. And then again, you have this time axis. I can see from 1962, we have increased our daily intake of calories overall around the world. And then we can also check different things, like we can check the meat consumption and how it changed throughout the time and throughout different countries. And then we can see China has increased its meat consumption a lot since 61 to today, basically. And then we can also see the United States as well, so that calories per person, 500 calories per person China has right now. And this is more or less similar right now with the USA. And India is very below because of the cultural reasons or some other reasons. And you can also see different type of countries, different events, what happened during this time. For example, try to understand that the things that the countries are going through, etc. These are the things that we can do with interactive visualizations. Then we can try to see also, try to analyze, try to play data detective through static visualizations as well, because this is what is called a Sankey flow diagram, and then it is designed to show what flows from one state to another. So in this case, what flows, kind of what is the energy flow from the inputs, raw energy sources, and the target, that is the energy consumer. So we have different types of sources, nuclear, gas reserves, bioenergy, solar, hydro, wind, coal reserves, oil, etc. And this is what UK wants to achieve by year 2050. So just by looking at this, we can try to understand what does UK want from their energy policy and energy lookout, and then how it will relate to different type of things. So we can try to find out also what these means, what these things in the middle, so that we can have these are the raw sources, and then you can have natural gas, coal from coal reserves, oil from either oil imports, oil reserves, etc. You can have the state of the material, either gas, solid, or liquid, how we treat it through thermal generation, and what we get in the electricity grid or heating, let's say. Then now we have a vague understanding of what this flow diagram is. We can try to find out, okay, what is interesting here? By year 2050, UK will use oil mostly for transportation and a little bit of industry. So that this is something that cannot be done, or somewhat hard to do with electricity still. Like if you have aviation, international aviation or national aviation, that is still you are relying on those liquid fuels, let's say. But then all the other things, different types of heating or industry are replaced with electricity grid. We can then find out where are the losses generated. Mainly, they are mainly generated in the thermal generation, and then this is a necessary step to generate electricity from nuclear, for example. If we can solve it if we had nuclear fission instead of fusion. So that is something to think about. And then we can also see here what is the outlook with respect to renewable energies and such. And then we can see that outside of this oil part, which is mostly used for transportation, the coal reserves and gas reserves are minuscule compared to wind, solar, and bioenergy. So we can now understand what UK thinks about their energy policy as well. So this was a kind of a quick data detective session to get the insights. Then, yeah, sure, we got the insights perhaps, but then how can we utilize AI for visualization?
Yes. So, but prior to jumping into the how can we use AI, I would like to take one step back and think about how we can visualize data. And mainly we divide this up into two parts. One is to use already available applications. You saw Gapminder as a web service for a certain type of data. This is an example of Tableau, which is a more generalized visualization tool to allow you to use different types of data by more or less just a set of different drag and drops operations. So we, for example, have we have the X and the Y columns, where once we have imported data, we can take parts of that data and draw to the X and the Y coordinate of this this final visualization that we're going to create. In this case, it's creating a map. So we will use the longitude and latitudinal information in the data to draw to these two different X and Y axis. We have markings, that is, what is the actual glyphs, graphical elements that is going to be presented on this visualization. What are those going to be driven by in terms of data parameters? You could have a graphical circle like in this case, and the circle has a radius, it has a color, it might have a transparency, and already there you have 3 different parameters which you can take parts of your data and update those parameters with, right? And to the right there's a plethora of different visualization methods that you can then select, and then obviously that changes what type of parameters in the visualization you can update. And you just more or less need to connect the data parameters with the visualization parameters, and then you have your visualization. That's the application point of view. Very straightforward, very direct, very potent tool of visualizing your data. But once you may come to a position where you want to be more specific, you have more specificity in your requirements, and you may want to have features and interactivity that you don't have available in these already sort of general pre-made tools. We need to go for the programming route. And that could be arbitrarily complex, obviously. And this very special example is quite a simple case, which could be as easily implemented in the left column of a tool. But still, it shows you a way of then more explicitly define what you're actually doing. If you have knowledge about how your data is actually constructed and how sort of the underlying physics of your data is working, then you might benefit from actually being able to explicitly define that in programming form as well. But the flexibility comes at the expense of complexity, or I mean, they go hand in hand. So how to go about it? If we need the complexity that is not present in a tool, but we also are then exposed to a complexity that we may or may not be able to fully handle, how should we then go about it? Well, we could either like ask an expert or become the expert. That's like the general truth, right, when you're exposed to a problem. Fortunately, here we have AI as a tool again then to bridge this gap. If I'm not able to hire this expert that would allow me to visualize my data, and I don't have the time to necessarily become the expert that I need to be in order to get the flexibility and the type of visualization that I'm aiming for, AI could help us with that. All of you have been trying out ChatGPT, I hope. Is there anyone that has yet to jump into the wagon of ChatGPT? Yeah, there are a few. You're in for a treat. As you know, ChatGPT is text-based. It is, as we heard this morning, based on a foundation model that is text model. We also heard that it is quite efficient at mimicking what this morning was said to be defined as implicit knowledge. And it is getting more and more able in doing this mimicking, or this faking, if you would like to say so, or maybe we are all just statistical machines faking things. That's something for a later discussion with a glass of wine or whiskey. But it's also very potent in being able to perform these other tasks that are not connected to large language processing, which includes visual analytics, which includes visualization, and being able to have this as a programming aid, as we heard this morning again, referring back to that talk a lot, I just realized, but we also have had the ability to get assistance when coding for a bit longer than what we've had in other fields of technology. So let's focus on this, because this is something that many of you have already tried, and a few of you will have a treat trying this weekend. There are other alternatives. I feel like I'm obliged, since I'm from the university, almost like saying like Swedish television, we are not favoring any company. There are other alternatives to the services that OpenAI provides. But for simplicity, let's go for that, which is ChatGPT, and this is ChatGPT Plus. Meaning that you have access to the latest models, and you also have access to the functionality that I will talk about now when it comes to visualizing. And that is actually two paths. Once you have your GPT Plus account, you have two paths to continue when you want to have help with doing your visualization. One is to use the OpenAI sort of built-in beta functionality of advanced data analysis. And advanced data analysis doesn't say anything about visualization in its title, but as we saw previously, visualization is a very potent tool to analyze your data. So it's implicit that we will be able to use this for visualization. There are other plugins as well that could be used, but we put that aside for this this talk. So the procedure of using ChatGPT for this is to then just enable this advanced data analysis, allowing you to start chatting with your data. But obviously you have to provide the data. There's a small icon here to the left, a plus sign, where you then click that and you then upload your data. Or you can even just drag and drop, as we talked about in this tool section of ease of use. So you can take your data, drag it in, and then once it's uploaded, you can start having a chat about your data. And the idea then is to have ChatGPT produce code for you, like produce Python code that will analyze and visualize your data. Once you've done that, you may get images. Images can just be copied and pasted into documents, obviously. You might have new updated data. Data can just be downloaded in another form than what you had previously. You can maybe end up with code that is really what is creating your visualization based on your data, and then you can download the code for further then processing. So this is not like maybe taking you to the end of what you require in terms of visualization, but it's definitely a very strong step forward when investigating visualization. As you may have seen when you have been using these tools, sometimes you get good results, sometimes you get somewhat results that could be maybe improved. So iteration is key. If I were to upload a data set and just ask, give me a time plot of this data, this might be what I get as a result. And we're staying with this environmental data still, because it's cool. Yeah. And important. It's hot even. That was such a good remark. Note to myself, remember. But as you see, this is maybe not the visualization that you would like to copy and paste into your PowerPoint in order to present a main idea that you might have. There's a lot of things that you will find here is not that good. And if you have a visualization understanding, what should we do, what should be a good visualization and what should not be, you can easily spot this without having to code and create it. But it's often more easy. It's more easy often to grade something that you're exposed to rather than generating something, right? So having this to generate and then being able to say, these numbers of years just looks a mess. And I cannot really know from at least this projector, maybe you are better at me than that, but which line is which, it's not really fully that clear. So then I iterate and I chat with my data saying, well, could you please do this? Could you please update? And you should be, you should say please. And you can then get something that is more clear, that will allow you to a bit better see what's going on. And you can maybe tweak it a little bit if there's some more details that you would like to have. Maybe you want a legend to be more informative or whatever. And then you have that image, you copy it, then you paste it into your document and you have your results. So what to consider in this case, as in always the case when it comes to using these types of tools, are that prompting is vital. That is, what are you asking the model to do? If you're vague, you will get a vague result. If you are explicit, you will get a more clear, explicit result that maybe reaches or meets your expectations. You don't necessarily know in advance what you're asking for, so that's why you then have to employ this iterative procedure. But as always, technology, it's a truth more or less like a physical law. If you put garbage in, you get garbage out, so let's try to avoid that. Sharing sensitive data, that's a problem in these cases, right? Because if you want to visualize maybe your corporate data, do you want to just send that wherever? Obviously not. You want to be very sure that your data is handled in a proper way. In the current version, if you just use ChatGPT now, that data will be used for training future models. So one should be very careful about that. There is a solution, obviously. There are enterprising tiers, except for the free, the plus. There's an enterprise tier where you can feed data into the model and it's not being stored or used for training. So you can, if you're safe with using Google, if you're safe with using AWS or Microsoft, you should be able to be safe with using enterprise tier on OpenAI as well. Or if you have time, if you have money, and if you have the interest for a weekend, you can set up your self-hosted system as well with an open source large language model and build on that. It's not that complicated. Fascinating, but it's not. If you want to do more complex visualizations, plugins is mainly the way to go. We won't talk about that. We will talk about it after lunch though. So join us for the plugins discussion.
Yeah, that's actually a great segue into this. So assuming that now you're interested in visualization, data visualization and data visual analytics, so how can we support you? We are here to support you. So if you're professional individuals, please join our talk this afternoon. If you are from companies or institutions, I'm employed in the InfoVis project. I will talk about a little bit more. And then if you're researchers, you can get help from InfoVis project. So InfoVis project, I know there are two similar word-wise, but InfoVis project is what employs me. I'm funded by InfoVis project as an associate senior lecturer, and then its aim is to support industry and society on information visualization through research and education. And then we are giving seminars, data clinics, and tailored research support in the form of student theses, for example, and then we can develop courses as well. And if you're a researcher, then there's InfraVis National Framework on visualization support. It is basically composed of 9 different universities through Sweden and funded by Swedish Research Council. And then researchers can get 3 different levels of support through help desk, mid-level, and in-depth support. If you are interested, please contact us. So we are here around all day. If you have any questions, you can perhaps ask it now, or you can approach and we can have a talk, definitely. Thank you.
So thank you so much. Are there any questions now that you would like to ask? Yeah.
Question about protecting data. You said you should protect your data, but how do the model protects for fake data? If you use fake data and put it into the model, and then it will be spread if many people do that.
Yes, that is a problem. Even if you're not maybe doing it consciously, there is a problem with bias, as we heard during the presentation this morning as well, that the models might contain information that is not as evident, that is not evidently wrong or evidently not what you want to have in the model, but it might be there regardless. If your question implies that what happens if a lot of people start to use these to add bad data.
Tamper.
Some kind of investigation to prove that their product is good, and they put it in there. You should protect it, but then of course if someone else are using this, then they think this fake data is true.
Yeah, and you raise a valid point, which is something that all of those that creates these foundational models need to address. How can we make sure that the model provides the functionality that we want to, and not enforce behavior that is not something that we need? I think the jury is still out on how to really ensure that that is happening in the way that we want to. If I were to very unscientifically relate to how we work as people, there is some kind of trust system that needs to be introduced, right? Because you trust hopefully a bit of what we've said today, but how can you be sure? So
yeah, and right now, I mean, in the form of ChatGPT, they are used in researching how people interact with the system, and I hope that they will kind of filter out those fake information as well in the meantime.
Good question. One more here.
Oh, hi. You talked about going from numbers to images, right? Yeah. So, but sometimes, I mean, in research, you have a situation whereby your result came as an image, like a plot. For instance, the Napoleon soldiers marching to Moscow, right? So sometimes you need the figures to do some programming. So do you have research or tools, or are you currently doing a research whereby you extract the numbers from the images and have figures in this case?
No, in short. But yes, there are research on that. We don't do it, but then yes, there are research on that as well. So that you can use to, but it will not be always accurate because you cannot always trust the visualizations. We will try to show that in the afternoon session, so that depending on the type of visualization and depending on what type of people create those visualization, there's always a trust issue as with all the people, so that you might not trust the data that you extract from the visualization. Exactly.
Just to piggyback on that, when it comes to ChatGPT, quite recently, it's like it has been launched within the last 3-4 weeks, 3 weeks, I think. There is now an option of you inserting an image rather than text in your prompt and have the model analyze the image. So there is ways of being able to, for example, feed it a graph and get it to analyze what that graph contains. But you have to validate the extraction that comes from that, and whether the numbers, for example, that are extracted from a graph is correct or not.
Thank you for your nice presentation. I have actually 2 questions, maybe a bit technically. The first one is related to the visualization for high dimensional parameters. I mean that is there any possibility to visualize a data set, for instance, at the same time when we have a lot of features, a lot of parameters?
Yes, I mean, you can only visualize, because the end user of visualization or visual analytics are humans, so that you need to reduce that feature dimensionality to some point, that you can use the different kind of dimensionality reduction algorithms and then different type of data analysis methods or statistical analysis methods to find out what are what type of features are important or attributes are important, what are not really important, so that you can reduce it to a number that you can understand. Or you can also do it in subsets. So you first analyze some subset and move on to another, and then try to build insight from that.
Thanks. The next question is regarding to, you just explained that how we can use AI for visualization. My question is vice versa. I mean that, is there any possibility to use visualization for improving the machine learning models, for instance, interpretability and something like this?
To some extent, yes. The problem kind of relates to your first question, meaning that these large language models or these AI systems contains actually billions of parameters. And when you're doing your visualization, at the end of the day, you're going to produce an image. There's not that many dimensions there. Sure, you have X, Y for the size, and you have color and transparency and things like that. But going from billions to maybe tens is a very big step. But sure, there are a lot of work trying to use visualization and use other tools to understand these models and how they work.
You can start with understanding parts of it, perhaps. And
Thank you so much. Time's up now, and it's time for lunch. And we will be back here at 1:30, and then we will switch language to Swedish and talk about digital, god och nära vård. But you can join Roger or Emin at in a practical workshop, or not a workshop, but a seminar.
Yeah, it's a little bit more practical, and then we will try to show you how to improve your communication through visualizations.
Yeah.
So you're all welcome.
1:30. 1:30. Yeah. So thank you, everybody.